another maintenance modeling and analysis lesson. Today we will talk about the importance of maintenance. So we will give the fundamentals, the basics of the maintenance course. Again, as usual, let me introduce myself. My name is Marcia. I am an assistant professor at TU Delft and I give the course of maintenance modeling and analysis. And my research interests are basically predictive maintenance and prognostics in health management. So, after saying this, let's see what's the learning objectives for today. So, what will we talk specifically today? Today we will give an introduction to maintenance, as I have already mentioned, and I will talk about things like what is a failure mechanism, so what leads to the failure, and what is a failure mode, so how does the system breaks, and how these two concepts are connected. Other things that we will talk about is failure and maintenance, and what is failure, what is maintenance, why one is a contrast of the other, and why one has to happen to prevent the other. We will also talk about concepts that are important to fully understand what is maintenance and what is failure, such as operational conditions. Operational conditions being things like whenever the aircraft changes speed, then it changes operational conditions and it changes the whole modus operandi of the aircraft, for example. We will also talk about function, functionability, what it means to function, how can we define it, because we can say something is functioning, but what does this actually mean? How can we quantify that? Okay, and I will also give an example of, I'm not going to say already what it is, but I'm going to give an example of a maintenance activity that happens, for example, in all the airlines, and I will give the specific example of KLM. So stay tuned. So let's start with the first learning objectives, fundamental concepts in maintenance. There are many different definitions of maintenance, but the one that I like the most is the one that says that maintenance is a continuous process of operational optimization. Let's break this down into pieces. So the first thing is that it's a continuous process. It doesn't just happen when there's a failure. It happens way before in the planning and scheduling and doing everything to foresee failure. So it's like something that is always happening in reality, while most people think that it's something that just happens at the failure time. Okay? Another thing is that whenever you project, whenever you plan, whenever you schedule a maintenance activity, you have to balance certain things, like the costs and the benefits, because there are always benefits in doing a maintenance action, such as optimizing performance or not. You have to check, but there's always the costs also. So, some examples of maintenance activities. For example, fuselage repair. So you have what we call structural health monitoring, where you try to maintain the structure of the aircraft in its best condition. You also have something that I really like, which is the aircraft bleed valves. I like it because I did my PhD, part of my PhD on that. And these valves are very costly and they break a lot. They have necessities of repair very often. And sometimes their failure is irreparable. So you lose a lot of money every time they break, because they can mean that the aircraft is put on an airplane on the ground position, and then you lose a lot of money. And they're also costly, which it's not very pleasant to always be replacing them to avoid airplane on the ground situations. So it's a bit of a hurdle here. And another example of a maintenance activity is, for example, when you have a fan and the fan has some problem, you can repair it, okay, or replace it. It depends on the degree of damage that the fan has. So now let's talk a very important maintenance activity. This is just an example to make you understand the entire context of maintenance. And the example that I want to talk about is engine overhaul. Engine overhaul is a word that everybody knows in the airline business, and it means that you have to, from time to time or whenever there's a problem, you have to do a complete dismantle, repair, inspection, and put together everything again in terms of the engine. So basically the tasks are to dismantle, to tear apart the engine, then you clean it, inspect it, and service it, or in other words, you repair anything that is not okay. How often do you think this happens? Well, this happens every 30 to 3,000 cycles or every 5 years. So there's two limits here, the calendar limit, the 5 years, and the usage limit, the 3,000 flight cycles. If you don't know what a flight cycle is, very easy. It's just a flight that the aircraft operated. So five steps of engine overhaul. Let's start by the first. Whenever there's a overhaul, you need to prepare in advance for it. So you need to take care of the human resources, of the logistics, of everything, of the place where you're gonna do the engine overhaul, and all this has to be arranged and prepared ahead of time. Then comes the cleaning step, where you do cleaning, where you put the engine into several liquids, use several liquids to perform what they call a bath. So they basically clean the interior and the exterior of the engine. And then they're ready to perform an initial visual inspection, where they use a small camera that goes inside the engine and tries to figure out if there's something wrong with the structure, or some corrosion, or something that is not as they should. The next part is to finally disassemble the engine. So first you clean it and then you disassemble it. And when you disassemble it, you have very large number of parts. Can you guess how many parts there are in an engine? Well, there are about, it depends on the engine of course, but there are about 40,000 parts. So a lot of units, systems, subsystems, a lot of equipment here to take care of. And that's what we do in this step. We basically dismantle the engine, and then we go check if all the parts are okay. If they're not okay, they are either sent to a specialized shop, or they are taken care of by KLM, in this case by KLM, the airline. So what do they do with these parts, all of these parts that have a problem? Some parts may have reached their life limit. They're called the life limited parts. And once they reach the calendar limit, time limit, or a usage time limit, they have to be taken out and replaced by a new one. And usually these parts are not repaired again. What happens to the other parts? Some parts are repaired in shops because KLM has for example, has very advanced technologies such as robotics and other manufacturing machines that can take care of that parts without sending them to a specialized shop. All of these parts are many and they vary in price. So some are cheap, some are not so cheap. So if you look at this part in particular, the forward outer seal, how much do you think it's worth? Think in terms of Ferraris. So do you think it's one Ferrari, two Ferraris? Well, it's actually the cost of 5 Ferraris, 1.4 million euros. So a lot of money. And this is why we try to perform maintenance in the most effective way, to avoid costs, unnecessary costs, to prevent failure as much as we can, and to optimize the operations of the airline and all the other stakeholders involved. Finally, we have the assembly and the testing, which is assembling and testing. So you put everything together and then you use a test cell to make sure that everything is running smoothly. And then, if everything goes according to plan, you receive a certificate of airworthiness, which means that the engine can fly for 3,000 cycles again, or for more 5 years, or for some other period of time that they determine.